So the eighth step just contains just the settings local PHP that comes default with Drupal, extended with the database configuration that you can have locally. You should, yes, copy it in both directories for the subdomains, because both directories have a settings PHP of their own. How is it going for everyone? Done? Okay, then we have some done. I presented this link. On this link, you should be able to access this is the endpoint of the server from which you can get the JSON. If you don't have the project set up yet, then I will use PHP Storm and I will magnify it, and we can go through the JSON while Composer is doing its stuff. Yep. Okay. Okay. Perfect. So this is the JSON. I will scroll this a bit more. So basically, we are dealing with a reservation. The use case is if you have any kind of complex data structure, then we would like to use entities for that. And a reservation, even I took an airline example, a really basic one, but any reservation basically in any field is a really it's complex data, and usually there's loads of it. So you need a really great architecture to process all that information, and in the same time to make the code readable, make it scalable, and so you don't have performance issues either, and so on. So the response that you get is it's an array. There are objects basically which are keyed by the PNR, which is the passenger number. It has an owner, the person who made the reservation, and there are other the owner obviously has its own details. There are other passengers, because usually you can make reservations for different people as well. And they are the routes. Please disregard the stopover. I did a mistake there. We will not use that flag at all. But the routes have it's an array of objects that have departures and arrivals. And since a reservation can take you to many cities, many stopovers, there can be multiple departure arrival pairs in your route array. So while we have this, I will put that back on in a short while. What do we have to do when we confront ourselves with such a structure? The easiest way out, sort of the cop-out, usually is that, so what my experience has been is that we use the entities provided by core. And for this one, we can use content types and we can use fields and so on. But that's not recommended at all. The idea is to use the core entity types as less as possible. So we have to, and because our goal is to have a scalable application, then we really have to have a good database design. Therefore, I created a challenge. and I'm not sure if we can do this with how we have set down. You basically, you will have 10 or 15 minutes. I think 15 will be okay. You will have to do the database design, and we will review it, and we will see if it's normalized enough so that we can use it. Within our application. Obviously, as the workshop will go on, we will use my design because that's how the code was written. The best database designs, we have prizes for them. We have several tickets for DrupalCamp Transylvania next year, and the best 2 designs will get the tickets, because there might be that some designs might be the same or might be on the same level of normalization. If there are 2 equal ones, then the time obviously matters. So who submitted that design first and is good enough will get the ticket. So right now it's minute 27 on my laptop, and after 15 minutes, please submit your, or within, so who finishes first obviously can submit it. So go. Your task is basically to design what tables will have what primary keys, what properties, what are the foreign keys for those tables, and you will have to do this design on the JSON that was provided. Obviously, the data tables will not represent the structure of the JSON, so you will have to think and do the architecture yourselves. Have fun. So I created a paste bin with the JSON to be more accessible. I didn't think the submission part through properly. So if you have a design, then maybe you can write it down on pen and paper, or maybe you can show it if you have a database design tool already installed. So just please raise your hand and ask us to go there and take a look at the design. Okay, so we had 3 great, really good answers, and they differed quite a lot. So I will actually give all the 3 tickets for that. I actually thought that okay, so the time passed, but the ideas were, so the essentials were understood. We will have another challenge later, which I plan to give a ticket for, but I'm not sure that we are gonna get there in time to actually write the code. So I will ask my colleagues to take these 2 and give it here in the front row, and S.O.L.I.D in the back to the sir there, you and Mihai. So congratulations. If you have time to attend, then please join us next year in May. But so we will continue with what I thought was all right. For your answers, the times actually, so the routes themselves can have multiple times. That's why we have to separate them, So after we do the database design and we see how we can work with it, we have to design the model layer. And this means the model layer means is the abstractization over the database structure, and how the code interacts and what are the objects that are created when we load something from the database or when we load something from the web services. And since we are dealing with the same data, even if it's from the database or the web service, it needs to be something generic. And I will just go back to the previous slide, because these tables are actually the ones that were created after creating the entities and fields. So we have to design our model layer in this case to work together with Drupal as well. So we have the reservation, the customer, the passenger, the route schedule, and locations. These are the entities that we are working with. The reservation __, you will recognize these formats. So it says field other passengers and field route. So these are the ones that were added onto the reservation entity, which contain one-to-many relationships to their respective target types. In the case of other passengers, to passenger, and in case of routes, to the routes schedule. The reason why I separated passengers from customers is because usually the customer has other data as well. In our JSON, there is none because I wanted to keep it simple, but usually there are different identifications, there are passport numbers or other social security and so on. And other passengers might actually have just those three data, or maybe an email address buried somewhere in there. They are not customers of the airline. The owner of the reservation is, and that's why there are two separate entities. But because they contain similar personal information, then the customer can reference the passenger information, so that when we deal with this information in code, it's easier for us to create reusable methods, reusable classes, and so on. So after we identify what are the entities, what are the fields, what are the relationships between these, then we can start going ahead and implement these and to use them. So how do we use this data? What I'm proposing on this session is the data access object design pattern. This design pattern, I think, is the best pattern that deals with loading entities, processing them, and saving them back or updating them in the database, or display, or do whatever you want with it. But it accesses and processes the data. So we have four important pieces in this design pattern. The first one is the business object. The business object is the generic object that will be used by a tweak template, or that we will send to a different client. It's what we use in our business logic. The DAO, basically it's the class that is the data access object, is the class that deals with the database operations, and which can range from, just as well, create, read, update, delete. So this class is responsible for dealing with these. We have the data source, which in our case can be the database or can be the web service, basically the endpoint that we have created on the server subdomain. And we have a transfer object, which for the web service is a JSON. We can obviously make it more abstract if we want to enter into type hinting, and we can convert. But basically, from the web service, the transfer object will be a JSON, and we can decode it so it's an array. In the case of loading these data from the database, the transfer object will be the entity object itself. But we will come back to this a bit later as well, because we will implement one of the methods that has to be implemented in this design pattern. Along with this, I didn't put up the structure for it. We will also use the adapter pattern, and that is necessary because we want to change the transfer object into a business object, and the adapter pattern does that. It changes, it maps certain objects to another data structure, another object. So let's start creating the entities. The first that we will create is the reservation entity, because that's the most simple. I didn't write where you should create the entity, but it's under the entity namespace. So if you should have the reservation list module in your client.drupalaton.dev subfolder. And if you are on the first step branch, then that's all you should have there, I hope. But you should create the source folder, and under it the entity namespace, and within the entity namespace you create the reservation class, and the reservation class should have this annotation in the doc comment. I will give you a bit of time until you create this, and we can go on then. If we check the contents of the annotation carefully, we can see that it contains the ID. That's the machine name of the entity type, and that will be used in code everywhere. So, and it has to be unique. You will also notice that you have a base table key, which obviously says what table it should create after we enable the module, or after we run drosh entity end up. Yes. The last key, entity keys, is a more special key in the annotation. It's used in multiple places. Drupal does this sometimes, that it defines some structures which it uses for metadata definition, and it checks for the existence of those in several places. In some places it actually uses those even if they are missing, and this means that your code might break in unexpected circumstances. So it's a good advice to have ID equals ID as an entity key always in your content entity type definition. You can add obviously others later, but this one is just very important. Also, if you would like to use name, you are naming something, then you should use the label entity key, because that will you will have the label method on the entity class, and you can use that. It's already written for you. Okay, let's see what this is. Now, after you have defined the entity, there are several things that you should actually do. First one is that you should extend the content entity base class, because the Drupal has to know that it is implementing implementing a certain interface and so on. So you should extend this. Sorry. So that's the first thing that you should do. Then the second thing, which is very important, is let me just check what's the actual name of the interface. So your class, other than extending content entity base, it should also implement content entity interface. So these are the two requirements that you have to you need to have. And after these are done, you will have access to several methods from the parent class. And the most important one that we will use is the static function base field definitions. So we will have to call the parent method of that, and we will have to define our own fields. So what we will do is actually you can. So the name is base field definitions, and it returns an array of fields. If you take a look at the parent, you will see what's the actual structure. I will put the code on screen as well, so that you have a guideline of how it actually looks. So this is what it looks like. It's a static function because the object is not created yet. When the definitions of the annotation and everything is pulled in by Drupal, you need to call. You don't actually need to call the parent if you don't want to. The parent just gives you several definitions that are built in. For example, it checks if you have the ID as entity key, and if you have it, then it will create you a primary key with the name ID and so on. And it also has other useful definitions for multilingual, so you can basically just run through it a bit later and see what it's about. What we have created here is our own. Basically, we have the PNR that is a string that has a maximum length of 6. And we also are telling it that it sets the display configurable. It sets the view display as configurable. This means that if you go to the Manage Display tab that is not created yet, but basically it lets you configure the formatters for this entity if you want to use them. You can also have a set display configurable of the form set to true, which means that this lets you fill the widgets for your form entity, for your entity form. The second one is the owner, which is an entity reference. You will see at the target type, at the setting method, that we told it that it's referencing a customer entity. This means that the customer entity has already been written and it is in the person module. Most of these entities have already been generated or written. And we will just go through the code, and we will check out some branches, and we will see that they already exist and have been enabled and saved in the data, and their configuration has been saved to the database. Also, the last one is created, because it's always good to have a created property in your table. Because usually on bigger projects you need logging and you need to know when was somebody created, when was it updated, what were the operations that were executed on that particular piece of data. And usually clients don't ask for it, but when there is a problem, they ask you, why haven't you put it automatically? Why didn't you anticipate the problem? So it's always good to have it. It's just a column in addition, so it's really, really useful. And it's useful throughout the development cycle as well, because you can actually see if you have, for example, if you have written the code and there's a bug and it saves your data multiple times, then you can actually check when it was saved, or so you can. It helps a lot. Usually like created and updated, yes. But the idea is that in our case, a reservation is not updated. Usually, let's say in the case of an airline. You are not if you are updating your reservation, that is an extraordinary circumstance, and they will update it for you in an external CRM or a web service or somewhere. So the actual data that is being updated is not by user input. So our client side that consumes this data will only perform GET requests on this. That's why I have not put a change field there. Also, to implement a change field, we will see actually later. Let's go back to the slide. So we have done these steps. Now we will do it a different way, and I'm not sure that everybody has Drupal Console installed or the launcher, but because Drupal Console works from within the project, these two commands should be able to run. So please test these commands out, and we will see what they generate. And so you also make sure that you're running them from within the web subfolder. And if these commands have run, then we will take a short break, and then we will come back to continuing the workshop. Okay, so we will continue from where we left. What I wanted to achieve by running these two commands is generating the location module and generating the location content entity, but if these commands didn't work, and maybe you don't have a Drupal console up to the latest version, plus we only have half an hour left from this 3-hour workshop, Um, let's just skip ahead. If you have on stage changes, you can commit those to the current branch that you are on. And please check out to the branch called fourth step and run those Josh commands. So basically, we on the fourth step we should have almost all the functionality. With the fields created, with all the entities generated, and so on. Which means that we have some configurations to import. So we will import those. Because we have new entities created, we have to update the entities, the entity definitions. So that's why we need the Josh end up. And a good clear cache just for good measure. In a multi-site environment, unfortunately in 8, if you run it from the subfolder, it doesn't recognize it, or at least I didn't manage to get it to work like it worked in 7. So you always have to append the URI flag to specify which subdomain you want to run the drush commands on. So after these commands have been run, you should have all the functionality. And we will dive into the code a bit. I will explain the data access object and how it was implemented in a bit more detail. And if we have some time, then maybe we can write some additional code. If not, then I will just show my implementation and we can just roll with that. And we will be able to test. So basically we will be able to call the web service and display the data that comes directly from the web service. And on the same request, we will save those informations, and on the next reload, before the next reload, we will do a bit of magic hacking and to load the information just from the database and display it again. So that will be the final moments of this workshop. Whoa. Good. So, what when dealing with entities, usually we should probably use Drupal Console, unless we have some really specific structure and we don't need the back office support for it. So I compiled short pros and cons for writing manually and writing with Drupal Console. It's very reliable to use Drupal Console. It generates everything properly, but it generates too many things. Sometimes it doesn't generate what we actually need, especially if our database structure is just wildly different. Drupal Console assumes or will assume that you are trying to create a custom entity type which will behave similarly to the node entity, and this is probably not the case in for most scenarios. So if you have managed to run those rush commands, I will ask you to test if the location entity was generated properly, because we will have to add the locations. I didn't, because I had to segment the workshop into branches, which are basically different environments. I didn't export the actual content entities. So if you go to structure, you should have location settings link. which will give you a familiar back office interface. And we will go to the manage form display there to add the code to the form display. Does this work for everyone? So structure, if you're logged in, so yes, please log in first. It's admin, the safest. Sorry? Sure, yeah. So you need to check out to fourth_step and to run those Josh commands. What is great with entities, and this is what I'm trying to demonstrate, is that after creating them, after generating them, we have the entire Drupal API to work with, which means that we can customize how the form looks. We can customize how we display it on the page. There are some really good stuff written in Drupal that we can use. Also, you have, if you use the entity API to save the entity and not just use database calls directly, then you have access to wonderful things like search API, and so your content will be indexed properly. So it's really important to use it, to use custom entities this way. So after you manage to change the form display, please go to structure and location entities, which should give you an empty page. That is the listing page of the locations, and you should have a button that says add location, and I will ask you to add these 4 locations. So the first is name, and second one is the airport code, because we will need these to have the functionality running properly. In a normal scenario, we have other REST endpoints as well, which will import these information, just like customer information or locations or routes. These should, in the situation where you get to perform a GET request that gets you reservations, you should already have the database pre-populated with the information that you need. Is it okay? Can I move forward? Okay. Perfect. Then let's see how we process the data. So as I said in one of the first slides, we will use the data access object pattern. And I briefly explained what these do. Now, if we take a look at the implementation, what we are trying to achieve is to display a list of reservations, which means that I created a controller for that with the proper routing. If you take a look at that controller, which is in reservations list module, you will see that that controller will try to access the web service, and if there's some problem, it will try to access the database. Both of those calls are returning what we call the business object. In this case, an array of business objects, because we are displaying those information in a Twig template, and we have to have the same data there. So basically, the same objects with the same methods. If we want to display the PNR, we need to have the get PNR on that particular object. So they need to be of the same type. It doesn't matter where the data comes from. The behavior on the web page is the same. That's why there are two data access object services, one that deals with the web service call and one that deals with the database call. In Drupal's case, there is an attempt at implementing this data access object service, and it's called the storage, the entity type manager storage. These classes, for example, node storage or comment or all those, they are data access objects. They are performing the operations that we need on the database. They do the processing as well. For example, the entity API load has a static cache of its own so that it doesn't call the database multiple times. It has this, the save functionality, the update. So everything, if you need to actually change these functionalities, then if you take a look now in how your reservation content entity looks like after the checkout, then you will see in the annotation that there is a key in the handlers called storage, which means that we can define our own storage, which extends the generic one. And this is the suggested and best way to approach this problem. We shouldn't do database calls in our controllers. We shouldn't do database calls in our plugin methods or block methods or from wherever. We need separation of concerns, and for this we have data access object. Obviously the data sources will differ. One is a web service endpoint. The other one is an MySQL engine. So they will return different things and with different transfer objects. In our case, the entity type manager storage, the storages of the entity type manager will already convert the information and will create the entities for us. The way this pattern has been implemented, there is a module called DAO pattern in there. You can check that out in more detail. It basically does this. There is a data access object factory which will create our data access objects depending on what we want to access. And based on that, we load the data and we load the transformer or adapter service to transfer everything that we want into the business objects. So the challenge 2, for which I don't have any tickets anymore because I gave them away, this means that we will just have to write some code, and because the organizers know that we started later, then we have an additional 20 minutes to this workshop, so we can actually complete this challenge. So basically, I left out an implementation, and that implementation is located in So if you go to the reservation list module, there under the storage namespace, you have the reservation class, and it returns an empty array. So our challenge is to study where that method is implemented, see what it has to return. Basically, it will have to return it will have to return an array of entities, an array of reservation entities. How do we do that? We need to find a way to load it from the database. So however you want, we have to return an array of entities. Let's say that, so it's 49 now, so we have 10 minutes to build a query however we want, or use the entity API if we want. At the end I will show the preferred method for this. But you can optimize it or write it any way you want. We will take a look if you finished earlier, so good work. So there was a good question earlier, how do you get to test that this works? Well, let's stop from the coding for a minute. Because we have the load reservations by customer ID defined in a different service. You should go to the web service client module and see that under source we have web service and reservation. And we have the method defined there as well, which basically does the GET request to the REST web server. And you will see that there is an exception there. Let's just comment out the exception. And we should go to the route defined in the reservation list module, which is reservation_list /list. So if you access that URL in that routing file, then the controller will get the JSON, will save the data in the database, and after that is done, we will decomment the exception, and the page should return the same results after you have completed implementing the method. So if you access the route, then you will see the 2 PNRs that come from the web service. So 6 ones, the first one, and 11112, the second one. Did this work for anybody? Yeah, okay, yeah, sure. I'll show the code. So it's web service reservation, yeah, in the web service client module. This exception needs to be commented out. Yeah. The reason I chose this approach to put the exception there and to just decomment or delete it, because I didn't have much time to implement update functionality, just the save. So if you go to the URL and you refresh, then it will save all the entities again in all the fields, so it will duplicate the data. This way I can load the page once, I can display my data and save it, and just put that exception there and load the rest from the database. Did anyone succeed with displaying the page? Okay, so that means that the code works. Thank God. So ideally, I mean, we have 10 minutes left. So it's a bit hard like this. So I will just show my code that I've done, that I had here. If it loads it. Oh yeah, here. Still change this. Good. So basically, we need to load the customer first, because we don't have the customer, the ID of the customer that we saved in the database. We only have the ID of the entity. We have the customer ID, but we don't have the entity ID. So what we can do is to use the entity manager property that this storage class already has, because it extends the proper parent. This is why it's good to have your own storage class, because it gives you access to anything you want while you are dealing with database operations on entities. So we are just loading, we are loading in the customer entity type, and we are loading it by properties, by customer ID. What this does in the backend Drupal, Drupal generates an entity query. If you have worked with this in 7 or even in 8, then you are familiar with entity queries. Entity queries will return an associative array of version ID as key and entity ID as value. So you should be careful. If you have revisions on your site, then you need to be careful what you are using those IDs for. We actually had problems with this in production because we didn't load the proper entities. So we loaded the version IDs, so it was a big mess, and it was hard to debug as well because it's not documented anywhere and it's just there. The array is just created magically, so we had to dig in a lot. So first it creates an entity query, it runs it, then it loads our entity based on the property that based on the result of that entity query. So in the entities variable, we will have an array of entities that are already the entity objects. That's why I use reset there, because in our case, we can assume that there is only one customer. However, the reset is not so great if there is a bug when while the saving occurs. But I'm not aiming to show 100% bug-free code, just how to approach the problem itself. And again, because you are using storage, you have access to the load properties method, and you can just load it by the customer ID here. So this is one approach. Obviously, if you have loads of data, then it has the database property already on this. You can build your own select if you want. So basically, anything goes. The idea is that this is an entity, right? So no, sorry. This is a method defined on an interface. So I'm not sure if I defined the interface correctly, but the idea is that you should return the same type every time that is defined on the interface. In this case, so basically you need to have type hinting. That is why we are using design patterns and we are using separation of concerns, because we know that we know the input in each step and we know the output and what messages and what types come out of these steps that we defined. So in the end, when the data comes back to us, we can, if there is a bug, then we can identify it almost immediately. And also maintenance is a lot easier this way. And extension, obviously. Okay, so let's get back to conclusions. So one of the main ideas for which I wanted to do this workshop is I would like to see increased code quality. Drupal core doesn't always provide it, almost never actually. There is no S.O.L.I.D in core. It tries to do it in areas that were written from the ground up, but things that were ported from 7, it's a mess. If you just take a look at Form API, for example, good luck with that. So by using design patterns and using custom entities, we are making our own code more readable. We have separation of concerns, which means that we are less prone to have bugs in our code. Because we are using solid guidelines to write our code, we make our code more testable, which means that it will be less bug-free, but also more scalable as well. And if you have client evolutions, then you can plan for them with a lot more precision. And better maintenance and lifecycle of the project. This is the result of everything that I just said before. Also, this obviously impacts estimations on projects, because as you've seen, and if you take a glance through the code, you will see that there is an underlying architecture there. And when it comes to the implementation, you really have to be careful and you have to plan it properly. But once that architecture is done, you can easily build on it and you can easily extend it. So the initial framework, as I said, takes longer. It obviously takes longer than clicking and setting up content types and fields, which will create you millions of tables in the backend and will slow your site down. But when an evolution comes or when a bug report comes, you will be able to spend a lot less time on finding these issues or estimating them. And when you have separation of concerns in the code, this automatically means that you can plan for those concerns that are separated separately. That it's in the word, so that means that you can actually give individual estimations and more precise ones. So this results in better planning, more accurate deadlines, which we all need in our projects. And maintenance cost is reduced because we can easily extend the functionality by adding another layer, or maybe just adding something to that factory, that data access object factory that just takes data from another repository. So there are lots of pros for using custom entities and using custom entities like this, like we've ran through in this workshop. So good luck with using these. I urge you to use them. It helped me tremendously. After I've started using them in 8, and I still had projects in 7, and I had to work on those, I converted everything to custom entities, and it just made my life a lot easier. So good luck in your work, and please enjoy Drupalathon, and please write higher quality code. Thanks.